Greetings, everybody. So here's a problem from our assignment that will give me an opportunity to tell you about the alternating series test. And in addition to me just going through the test, I've got to decipher a lot of the way that the question is asked in order to give my final answer. All right, so we'll do all that. So here I notice that I'm given an alternating series to start with. And before we get into the details, let's look at the big picture about what the alternating series test is. Okay, it comes down to this. How do you prove if an alternating series converges or not? Okay, I'll say for now, for this video, an alternating series will converge if I can show that all terms past a certain point in the series are like this. Any term is bigger than the one that comes after it in absolute value. In an alternating series, some of the terms are going to be positive, some are going to be negative, and they're going to alternate. But about this condition, for all terms past a certain point in the series, any term has got to be bigger than the next one, just in terms of their absolute value. So you can forget about the signs. Okay, so that's the first condition. The other condition that has to hold is that the limit as n goes to infinity, oh my goodness, this should be infinity. I'm sorry about that. The limit as n goes to infinity, that is the worst infinity symbol ever, but I said infinity, of the absolute value, again, is 0. Okay, so if I can take this formula, if I can remove all the information about the sign switching, and then take the limit as n goes to infinity of that, and I get 0, it satisfies the second condition. Okay, all right, so those are the two things that have to happen. Now, the second thing is just a limit, okay? And we've done lots of limits so far to get to this point in calculus. For the first condition, how do you prove that any term is in fact bigger than the next term past a certain point in the series? Well, that will come down to finding the derivative of this in terms of absolute value and showing that it's negative for all numbers past a certain point, okay? So yes, if the derivative is negative, it means that function's decreasing, and that translates into any term being bigger than the one that comes after it. All right, so that's the alternating series test. Now let's keep that in mind and use that in, as along the way in this question to ultimately prove that it converges. Okay, so here's the series that I'm given, and I went ahead and I wrote out some of the terms like that. Okay, I used my calculator. I've rounded these numbers, but I wanted you to get a rough idea about what the series looks like if I wrote out the first 4 terms. Okay, and you might say, wait a second. I look at these terms, and it certainly looks like this is happening. The absolute value of any term looks to be bigger than the one that comes right after it. Like I get 0.14, then I get 0.04, then I get 0.018, and then I get 0.010. Certainly looks like this is happening. Any term is more than the one that comes after it. So doesn't it just satisfy this first condition as it is? Well, I mean, this is an infinite series. And this pattern would have to continue forever. Like I would have to know somehow that it's not just the first 4 I looked at where any term was bigger than the one that comes after it. That's got to continue forever. All right. And me writing out the first 4 terms or the first 40 terms or the first 400 terms won't prove that. So that's why we find the absolute value of that original expression, which in this case would mean just dropping that -1 to the power, because that's the only part of this expression that could possibly be negative. And then I'll go ahead and convert that to f of x notation, function notation. And to show this first condition definitively, I would need to show that the derivative here of this is negative, at least past some certain point. Okay, so here's the derivative. I use the quotient rule to find that derivative, and I simplify it and I get like that. All right, okay, and with this expression I noticed that that bottom part has a square, and so that guarantees it to be positive, because like no matter what 6x to the third plus 1 is, if I square it, it'll be positive. I guess the question to showing is the derivative negative comes down to showing that that top part is also negative, okay, because a negative by a positive is negative. So I take the top part, I solve it for 0, and I find that that top expression, 1 minus 12x to the third, is in fact 0 at 1 over the cube root of 12. If I test values outside of that, take a number to the right of 1 over third root of 12, put it in that, I'll see I get negative. Take a number to the left, put it in that, I see I get positive. So that shows me this. If x is more than 1 over cube root of 12, then the derivative is going to take this form. It'll be a negative number over a positive number, and that will make it negative. Okay, so that's how this first question here is delivered. It says, in order to show the first condition satisfied, that any term is bigger than the one that comes after it past a certain point, then we can say that that derivative is negative as long as the x is more than 1 over the third root of 12. So it's past that point that the series is going to decrease. Okay, so we showed the first one. Yes, any term will be more than the one that comes after it so long as you go past 1 over the third root of 12, which is only about 0.4 anyway. So second part is this limit 0? So it passed the first part of the test. Yes, the terms are getting consecutively smaller in absolute value. Second part, what's this limit? Is it 0? So again, taking the absolute value of this, just drop the negative 1 to the power, then apply limit as k goes to infinity. That's an indeterminate form. We could use L'Hopital's rule, reduce it to this, and it is 0, so it passes that second part of the test too. That's why in this part right here, the limit is k goes to infinity, ak is 0. So ultimately we'll say it converges because it passed both parts of the test. All right, so there it is. That's the whole picture for proving an alternating series converges. One other thing we can do, if you have the equipment, I'm not saying you'll be allowed to do this on the test, but if you have some kind of a nice graphing calculator that will solve certain kinds of problems for you, I could graph that derivative and see that it crosses over to be negative right here at 0.43679, which is 1 over the cube root of 12. So that's another option that you have for proving this part. In any case, I hope that helps, and send related questions my way.